Good afternoon and welcome everyone. This is a silent session, so just to check out the mic and know the audience, can I get a quick wave of your hands if your primary responsibility is incident response? All right, I see a few hands and I see a mix of folks here. So welcome everyone. Thank you for joining. I am Harikumar Subramanian. I work for AWS Professional Services and I support AWS customers' journey towards cloud. So today's session, it's for incident responders, beginners and intermediate and higher. So we will start today's session with a NIST incident response framework overview, how it is applied to AWS, followed by a very interesting case study from Citibank. Security is a very top priority for AWS. We have a shared security responsibility model where AWS is responsibility for security of the cloud and US customers are responsible for security in the cloud. What this essentially means is US customer have the ability to have your custom solution for security meeting your enterprise security needs. After that, we will get into a detailed case study with an interactive poll where you will be voting to select the topic you want to learn more from a containment perspective. Right. Since this session starts from a beginner level going into intermediate, for the veteran folks, this is a refresher, and folks who are new to incident response, this is where you start. So what is incident response? Whenever there is a deviation from baseline, either due to a misconfiguration or an external party's act, you need to investigate and respond. That is where incident response starts. It's a system of people, process, technology coming together to help you to detect, contain, and recover your system in case of a cybersecurity incident. Your people personas are your threat and incident responders, threat intelligence folks, and forensic analysts. From a process perspective, it's your incident response plan and strategy, your playbooks, runbooks, and finally, at a technology point, it's your SIM, associated tools, and custom scripts you have developed. So today we will dive a little bit in depth for incident response lifecycle, 4 pillars within that. The first pillar of incident response lifecycle is preparation. This is where you have most luxury of time in your hand. This is something you're doing when you are not facing an incident. This is when you plan and prepare for a team, build your team, have the right plan and strategy in place, develop your incident response strategy, enable the team with the right tools, accesses, and enablement so that they are able to do the incident response whenever situation demands. The second phase of incident response lifecycle is detection and analysis. Detection is identifying an event either through your logs or alerting mechanisms, or even one of your employee letting you know there is a suspicious behavior in their network or system. Analysis part basically goes in depth, finding out if the event which was identified is really an incident. And if it is an incident, what is its impact? What is its scope? How does it impact your business process? This information greatly helps you when you go into your subsequent phases of incident response. The next phase is containment, eradication, and recovery. Containment is isolating and reducing the footprint of your incident. This will help you to reduce your data exfil or other impacts as much as possible. And this is where sometimes you need to bring your system offline or circumvent the traffic, or access controls are applied so that your incident is contained. The next phase is eradication, where you remove the threat and bring your defenses higher, like applying a patch or updating your network firewall rules. The final step in this phase is recovery, where you bring back the system carefully, slowly, and with proper observation so that there is no reoccurrence of incident or a different incident. Today's session, we will go in depth on containment and various automation strategies within incident containment. Final phase of incident response is post-incident activity. You can compare that to an agile retrospective where you go through various questions you ask internally to your team. What went well? What could have been done differently? Document what you learn. Share that documentation with the rest of your team so that incident responders are prepared for a similar pattern of incident. If it happens again, they are better prepared to respond. All right. Today, let's dive deep into containment. For AWS customers to fully benefit their journey in cloud, their operational strategy must embrace automation. Infrastructure as code using CloudFormation is one such pattern where you can highly efficiently manage automated deployment in your AWS environments. So how does this matter for incident response? This forces your incident response also to be much highly automated and improves your speed of containment and recovery. This helps with your overall reduction in human error, improving your forensic quality as well. Strong processes are still required, so are your subject matter SMEs still critical. All the containment and incident response actions in cloud is done using API mechanisms. This helps you to scale across services faster and quicker than manual way of containment and incident response. This is essentially a shift in thinking, and which is very easier and simpler in AWS cloud. When you talk about containment, and if you see you have challenges within your environment or having difficulty, how you plan incident response, based on our interaction, AWS professional services interaction with customers over a period of time, we know the importance of containment and how you need to automate it. So if you need any additional help, always feel free to reach out to your account team and they can connect you with professional services who can help you with this. Today, we will go more in depth in containment, and let us hear from AWS customer and leading innovators Citibank on how you can automate your containment, improve mean time to response by more than 10 times, respond 24/7 without human error, and how can you scale the incident response as well as containment across various AWS services. Same time, how will you establish patterns which will help you to grow further in your security posture towards your end goal. For diving deep and going more in depth, I welcome Elvis on the stage. Thank you.
Thank you, Hari, and welcome everyone. Thanks for joining us. Thanks for being here and making the time. I know this is one of the later sessions, but we're really excited to be here and really excited to showcase something that we're very proud of because it's something that we built in-house from the ground up at Citi, leveraging cloud-native functionality like Lambda, Step Functions, and Damien. We'll go into all the details, all the technical details of that. And ultimately, how we created something that we call the Cloud Containment Automation Framework, or CCAF for short. And so let's dig into what we're going to talk about today. So we're going to split it into 4 sections. Firstly, we'll introduce ourselves from Citibank. And then next, we're going to talk about the why. The why is a very important question because it's really, what problem are we trying to address? Why are we building something like the Cloud Containment Automation Framework? Then we'll talk about the what and the how. The what is, what exactly is the Cloud Containment Automation Framework with the internals, how it works. And then the how will be a deep dive into some of the architecture. For the how part of this discussion, we're going to need your help. We're going to have a poll where you're going to essentially tell us what you want to see or what you want to deep dive in. This framework is very feature-rich. There's a lot of capabilities. So we'll need your help to decide which ones you want to see for the sake of time in this presentation. So let's talk about who. My name is Elvis Veliz. I lead cloud security operations at Citibank. I've been with Citibank for 10 years now. It's going to be 11 years this Sunday, but who's counting? I've held multiple roles. I've always been in cybersecurity, pen testing, purple teaming, red teaming. And then eventually I landed on cloud security in 2017 or late 2017. And, the rest is history, as they say. I love it here. I love the community. I love what AWS has been doing, helping us build these capabilities. So I hope to stay here for a while. On a personal note, I love to travel. There are some pictures I have here from my travels. I'm a big sports fan. Any Formula One fans here? All right, so a few Red Bull fans. Awesome. So on that note, I'm actually going to be flying tomorrow to Montreal for the Canadian GP. So hoping that Red Bull wins their 100th GP, so root for the Red Bull tomorrow or this weekend. And then lastly, I do have 2 cats. They couldn't make it to watch it in person, but they're at home. Over to you, Damien.
Awesome. Thank you, Elvis. So, just a little bit about myself. Hello, everyone. My name is Damien. Just a short bio about me. Cloud security engineer at Citi, primarily focused on the leading the development of the cloud containment automation framework. A little bit about me. I am multi-cloud certified, so I have about 3 AWS certifications and counting, and 1 GCP cert and counting. I have an undergrad in computer science and also a master's in cybersecurity, which I just finished like a month or 2 ago. I'm an AWS community builder, DevSecOps advocate and mentor for those who would like to break into tech and into DevSecOps and cloud security. It's not intentional; it just kind of happened that way. But I'm also a cat dad, father of 2 cats, and on the other end, I also love to play video games, watch anime, and drive cars or attend car meets and whatnot. So if you guys are into any of that, let's talk after this talk. Thank you.
So thank you. So let's dig into the why. So why do we need to build something like the Cloud Containment Automation Framework? And the best way to do this is to go through a very simple use case or scenario of what a realistic attack will look like in a cloud environment. So let's set the stage. So Finitry is an obviously fake organization, at least as of the last time I Googled their name. Hopefully that's still the case. But they're a fintech organization, and like many fintech organizations, afraid of being left behind, they've hitched their wagon to the whole AIML hype train or bandwagon. So with that said, they saw that AWS provides a very feature-rich service in SageMaker, a service that allows them to simplify and accelerate their ML workflow from data preparation, model data training, all the way to presentation. So taking advantage of all these great capabilities of SageMaker, they decide to set up a POC to essentially perform algorithmic trading as part of their model. So what you see here is a very simplistic architecture where they set up a POC. So you have the machine learning developer that accesses a SageMaker Jupyter notebook that you see here on the top. And then, they have the typical SageMaker role attached to that notebook instance. But they're doing some other things. They're doing some data enrichment with an RDS database. And they're storing those credentials in clear text in that SageMaker notebook instance. And then they have the typical machine learning data bucket for their training set data. So just looking at this, you could probably spot some security misconfigurations, some pretty obvious and blatant ones. Like, for example, just looking at the role or the policy on the SageMaker role, you can see that there's pretty over-permissive. There's also long-term credentials, which are a big security no-no. A lot of attacks happen because of these credentials get leaked, and this is going to be kind of a precursor to what's going to happen in our attack. And then lastly, again, database credentials that are stored in clear text in that SageMaker notebook instance. So what does an attack look like in this environment? So first, we have to make one assumption. And it's really not a far-fetched assumption. That assumption is that those long-term credentials get compromised, which again, if they're long-term credentials, they could be exposed anywhere. There's a lot of publications has been, as you alluded to here, that those credentials get leaked and compromised. That's one of the top ways to get into an environment or to compromise an environment. So for the sake of this presentation, let's assume that the machine learning developer committed their long-term credentials to a repo, and that's essentially how the initial breach happened. So what happens in a breach like this? Well, the attacker uses those credentials, is able to access the console or through the API, or get access to the SageMaker notebook instance, performs discovery actions, and then finds the database credentials that are stored in clear text. For just kind of a legend on this diagram, anything that is compromised by the attackers in orange, and then the attacker actions themselves, like gathering the database credentials, are in red. What makes that important is that, as you'll see later in the containment phase, we want to contain all the resources that have been compromised. So you could kind of see what's going to get contained when Damien goes into the deep dives. Progressing the attack forward or moving the attack forward, the attacker performs more enumeration actions, more discovery actions, sees that SageMaker role has permissions to do EC2 actions. So what does the attacker do? Launches an EC2 instance in the customer's VPC with a reverse shell back to the back to the attacker's C2 or command and control infrastructure. So you can see, some of the code here, the script that's basically in the user data to launch the reverse shell that gets caught by the attacker. So again, typical attack scenario here. Moving that even further along, now the attacker at this point is looking for the keys to the kingdom, or looking for some of the nice data that they want to exfiltrate out into their environment. So again, they had access to the RDS database, so they're able to access that database there, and they're also able to access the ML data bucket with those credentials. So they start gathering that data, and then eventually they exfiltrate that data out to their own adversary S3 bucket that they own in their own account, and it's going out through a VPC endpoint. And this has been a very well documented technique of not going out to the public internet to exfiltrate that, instead going through the AWS backplane through the VPC endpoint if it doesn't have the policies, proper policies applied. So this kind of shows you what the end-to-end attack is. This is the end-to-end attack with basically everything that's compromised in orange, and then all the attacker actions in red. So again, anything that's compromised would eventually need to get contained as part of the incident response lifecycle. Just to kind of show that in a different way, this is the MITRE ATT&CK for cloud. The mapping of those attacker techniques to MITRE ATT&CK for cloud. For those of you that are not familiar, MITRE ATT&CK for cloud is a comprehensive knowledge base of attacker techniques that are used in the wild and documented by MITRE. Citi is actually a founding member of MITRE for Center for Threat Informed Defense, and we actually were one of the partners or one of the sponsors and also collaborators of MITRE ATT&CK for cloud, which we helped develop the MITRE ATT&CK for cloud matrix. So this is essentially the attack that I showed you in the previous slides. This is the attack captured in a common vernacular that we could use to speak about this attack. Now, before I move on to what a response would look like for this particular attack, let me do a quick shameless plug here. And I mentioned that this was a semi-realistic attack, but it's actually an attack that we carried out in our own environment, in our own controlled environment, as part of our Purple Team function. So what we do on a quarterly basis mostly is we carry out this SOC IR hands-on exercises that we call them. We basically stage a realistic attack on an AWS environment, and then essentially measure our defenders. How do they react? Are they following the processes? Are they educated in the cloud environment and the tooling of the cloud environments? To make sure that the actual tooling that we develop actually works the way we intended it to work. So this is actually, validating that what we build, the processes that we have in place, actually work in real life as close to a real life incident. So with that said, we were hoping that we could collaborate and kind of divulge this information to a wider audience of how we actually conduct these exercises. So hopefully in the future we're able to talk about this in more detail. So let's respond to this attack, and we need to make another assumption here. This assumption being that this attack had to have been detected somehow at some point in this attack. At some point in that MITRE ATT&CK for cloud matrix, one of those techniques had to have been detected or detected on, essentially. What we have here is an example of a technique that would have been detected, which is impaired defenses, disable cloud logs. So as part of most of the attacks, the attackers will actually try to disable CloudTrail so that you don't have any more telemetry. And this is something that you should definitely be detecting on whenever someone tries to disable CloudTrail. This is something we actually have a detection on. What you see here on screen in white, it's basically a response or a detection from one of our guardrails detecting that particular technique. So the assumption here is that the attacker tried to disable CloudTrail. They got caught as part of this detection. Now, to be fair and to be completely honest, we have, and a lot of these techniques would have been caught by our detective controls. We have a very mature and comprehensive controls engineering practice. Actually, we have over 500 detective and auto remediating controls in our cloud environment, not specifically AWS alone, but in our general cloud environment. And I highly recommend, if you're interested, to see how those controls are being developed. There was actually a talk back in 2021. I have the link here of our controls engineering team talking about our control framework that we use and how we develop these guardrails at scale. So highly recommend for anyone to check that out. Before I go into the kind of the end-to-end response to this incident response to this particular incident, I want to just make sure that we stay on track, and the focus of this discussion is just going to be on the containment. The NIST incident response lifecycle, as Harry mentioned in the beginning, it's a long process. There's other steps in it. For the sake of this conversation, it's going to be our containment steps, or what happens when we contain resources or contain a particular incident. So, what would a typical incident response look for an event, for an attack of this nature? This is obviously very high level. This is not every single step, but this will give you a gist of how a typical incident will go in terms of from compromise to containment actions. So starting all the way to the left, the initial compromise took place. As you saw, there's some post-exploitation activities that take place by the attackers. They start, enumeration, discovery, et cetera, and then at some point in time, as you saw, there was a detection triggered that essentially launched an investigation or a security incident, and that was the disabling of CloudTrail logs in this particular incident. So while that's taking place, obviously, everything's moving in parallel. The attacker's not stopping or pausing, right? They're moving along their attack path, and they're performing more actions. They're looking for data, they're exfiltrating data, et cetera, while the investigation is taking place in parallel. At some point in time, the investigation reaches a point where we understand what got compromised. We understand what needs to be contained. We talk to the business. We get approval through various forms that we need to contain these resources. They understand that their database has to be down. They have to move that data on-prem or whatever the case may be. But there's an agreement in place that we cannot let the attacker linger in our environment anymore. We have to contain these resources. We have to stop the attacker from being in our environment. And that's where containment actions take place. Now, one thing to note, or you probably see it right away, is that in this particular scenario, it took almost 4 hours to contain just a few resources. So again, 4 hours that the attacker could have been moving laterally, could have been compromising more resources. So 4 hours is a very, very long time, especially in a cloud environment. So why did it take 4 hours? Mainly 3 reasons why it took 4 hours. First and foremost is because containment was something that traditionally was being thrown over the fence. So what does that mean, throwing it over the fence? Well, security teams did not have the break glass access required to perform containment actions in our production environments, for example. So they couldn't perform the containment. This is something that's traditionally taken care of by our cloud operational team, which has that break glass access into the environment. So how it worked was that security teams created very comprehensive runbooks of how to contain particular resources. They're very detailed, very long. Actually, I had in the previous slides, I had a picture of what a runbook will look like in this environment, but it was just like 25% zoomed out, and you could still see anything. So it wasn't really worth showing it in the slide, but that gives you a sense of just how big these runbooks were. And you're asking non-security people to run through runbooks step by step containing resources, which is really not practical, and brings me to the second issue, which is manual errors or manual actions which cause errors. And that's the case when you have traditionally non-security folks following very long, complicated runbooks to contain resources in a cloud environment. We saw a lot of these manual actions. For example, if you use similar naming conventions on role names, a role may have a similar name. You fat-fingered the role name, and all of a sudden you're containing an incorrect role, which causes an outage somewhere else. So big issue there. And then lastly, and probably the most obvious to people here, is that scalability, right? We were only talking about 5 or 6 resources when we were talking about this incident. However, in a real attack, the attacker may launch 50, 500 EC2 instances into an environment, crypto mining or whatever it may be. But you need to be able to scale those containment actions to be able to account for that. So these are the 3 keys. These are the why we need to build something like the cloud containment framework. So hopefully that gives you an understanding of the why. And now I'm going to pass it over to Damien to give you the what and the how.
Thank you so much, Elvis, for the baton pass. So in this section of the presentation, we're going to talk about the how. And the how, not the how, but the what. Sorry. So in the what, we're going to talk about what we've developed at Citi, which is called the Cloud Containment Automation Framework, to kind of eliminate the the scalability issues and all the issues that we just covered from an incident response perspective. So the Cloud Containment Automation Framework is a framework that was developed by Citi engineers, and it pretty much focuses on the automated containment and collection of several AWS services. So of course, with the actions will vary based on the AWS service that we wish to contain or the resource of the service. We also support more than 10 AWS services for both containment and collection purposes, which we'll cover in previous later slides. And from a forensic standpoint, we also support the automated snapshot collection of RDS clusters and instances, EC2 instances, and also EVS volumes and that are standalone and also attached to those instances as well. Some key features of the overall framework is that we do leverage AWS CDK to be able to provision our core infrastructure. This includes KMS keys, S3 buckets, SNS topics, et cetera, et cetera. It is also integrated with several processes within Citi and tooling, for example, like Splunk. We also support cross-account containment and snapshot collection, which is also something that I'm going to talk about more in the next slide when I explain the architecture. And then to enhance the user experience for our incident responders, we also have a dedicated CLI tool that will execute those containment and collection state machines. So I'm going to move into the next slide, and what we're going to do is just talk about the architecture of CSAF or CCAF, right? So the first thing that the incident responder is going to do, so I'm going to start from the left onto the right, is that they're going to log into the AWS console. And that incident responder should have a containment role, right, that's associated with their profile or they have access to. So when they assume that containment role, what they're going to do is navigate to the step function or pick the step function that they wish to contain or execute the containment actions for. So, for example, if they are trying to contain an EC2 instance, they'll choose the EC2 containment step function, and that step function is going to require them to enter a payload. All right, so once they construct that payload, they're going to execute the step function, and then the fourth step, which is going to be that step function is then going to execute the Lambda function and pass that payload into the Lambda function of its choice. That Lambda function has an execution role, which has a policy attached to it that only allows it to be able to assume the cross-account role, which is deployed in a AWS tenant account. And from there, what they're going to do is that cross-account role has permissions to be able to execute the list of containment or collection actions that we wish to take, right? Once that's taken place, it's going to send all of that information back upstream, which is where we get to step 7. And that information that wherever resources we created for containment purposes, including the target account ID, the resource name, et cetera, is going to be sent to the SNS topic. And then from there, there's going to be all of the people who are subscribed to that SNS topic, whether it be our stakeholders for incident response and SOC, they're going to receive a nice, pretty email that explains what happened. So if you take a look at the image at the bottom right, you'll see that for S3 containment, right? These actions were taken successfully with the containment toolkit or the automation framework, and it gives them a summary of the bucket that was contained and also the target account ID. So with the next slide, it'll just kind of go into a little bit of a deep dive on how we basically leverage AWS CDK to be able to deploy our core resources. So with CDK and Python, our stacks are pretty much templatized, and it makes it a lot easier for us to be able to extend the features to new services when it comes to deploying or trying to develop new containment and collection capabilities for our framework. So we ultimately use AWS CDK to create that core infrastructure. So you'll see that all of those step functions or state machines for the framework, we use it to also create the SNS topic and subscription filters for Splunk ingestion and so on and so forth. We also use it to be able to create all of our core Lambda functions. So each step function has a corresponding Lambda function. We also use that to create the core AWS KMS CMK, which is used to be able to encrypt the communication between services and also the data at rest for those S3 buckets, the SNS topic, and so on and so forth. And then the last thing is that we also use it to be able to deploy all of those cross-account IAM roles with the permissions and policies included inside of it as well. And then if you take a look at the image on the right, this is pretty much a long, nice list of all of the YAML files that are created once we execute the CDK synth command or attempt to deploy this into our AWS environments, right? So in this slide here, we have a couple of pictures wherein we're basically an example of some of the CDK template, which we also use to be able to create the step function or the Lambda function. So you can see here at the very top, you see on the line number 2 with the picture with the red border, you see that it's the name of the EC2 containment Lambda. You can see that we also create the log group, and there's also a subscription filter so that Lambda function can definitely send all of its information into a log group that's in a different account that is used for Splunk ingestion. The picture with the purple border is essentially the CDK code that we use to be able to create a state machine or a step within a state machine or step function. And then the one in the orange border is essentially the core Lambda code wherein we are making those Bodo API calls to be able to interact with the back channels within AWS, to be able to pretty much modify the instance and attach a security group, which is going to basically deny all the ingress and egress traffic for that EC2 instance. So this is an example ultimately of how our code base is set up and ultimately what a CDK generated template looks like, and some of the code that we have for our Lambda function as well, just to kind of give you guys an idea of what all of that looks like. So now we kind of covered the what, and we've kind of introduced what the cloud containment automation framework is. So now we'll get into the how. So how do we use it, right, to be able to secure our resources and our assets? So this is where we're actually going to need your help, because we have quite a, like we said in the previous slide, Elvis said, it is incredibly feature rich. So it will be nice for you guys to fill out the poll that we have. So if you just scan the QR code or you type in prod-livepolling.awseventservices.com, that'll give us an idea of what it is that you guys would like to see, and we'll go through and we'll take a deep dive on it and explain it. All right, so the results are in. So looks like some people are still filling them out. Ooh, tie. We have a tie. Somebody break it, please. All right, so we got 8 and 8. So looks like EC2 containment and IAM user containment is what you guys want to see. All right, so let's move on back to the slides, and we'll go ahead and we'll kind of go over those containment features, right? Those are actually my favorite ones. So I'm going to just kind of skip. Oh, nope, go back. All right, awesome. So containing an IAM user. All right, so like I said in the previous slide, when we were going over the architecture, you can see that the first 3 steps are pretty much redundant in this slide. So I'm just going to focus on 4 through 8. So in this particular case, the first thing that the incident response is going to do, once they construct that pretty payload that we need, that pretty much contains the IAM user, the user's name, and the account that is being created in order to associate it with, the first thing is the step function is going to essentially go through this nice little pretty states right here. And the first state is going to go through this validate parameter state. So within that state, and the generate report state and generate error report states are pretty much the states that are included in every step function we have, is going to validate the template, it's not the template, but the payload that's being supplied to the step function. So once that checks out, then the next thing it's going to do is going to delete the user login profile so that they won't have the ability to be able to use that user to be able to log in anymore within AWS. And then once that takes place, then we're going to create a deny all policy that pretty much denies all access to all the services within AWS for all the resources, and it's going to attach that to the IAM user. And once that takes place, then it's going to delete those access keys that may have been generated for CLI access, along with SSH public keys for those EC2 instances, And it's going to delete the service-specific credentials if they have any access to any other AWS resources or other AWS services. And once that takes place, it's going to generate that nice, pretty report for our incident responders and just send it straight to them and let them know what has been created, what we did to contain this resource, et cetera, et cetera. And then if you take a look at the images at the bottom, you'll see that we have the deny all policy, and you can see that the effect is deny, action is star, and the resource is star. And you can also see with the trusted entities, for example, if there is a service that we're trying to delete things for, or we're attempting to, we are containing that user, we can see that we have a situation where we're adding a conditional statement for the role itself, so it permits or prohibits it from being from entities assuming it to be able to carry out additional functions. So this is an example of what we are doing for IAM user or containing an IAM user. So the next thing we're going to do is talk about containing the EC2 instance, right? So again, 1 through 3, the exact same. We get to step 4, and what happens is that Lambda assumes that car role has permissions to be able to execute these containment actions within that tenant account. And from there, we're going to move through these couple of steps. So the first thing it's going to do is going to detach the instance from the auto-scaling group. And once it finishes detaching the instance from the auto-scaling group, it's going to contain the instance network traffic. So all of the current security groups that has been associated with the instance will be removed. It's going to create a new security group with no egress or ingress permissions. And it's going to associate it with that EC2 instance, and only that one, to where it won't be able to have any kind of access, no traffic going in or out. After that, it's going to disassociate the instance profile and any other IAM roles that are associated with it within that instance profile. And then once it's finished with all of that, it's going to stop that EC2 instance from running. And then it's going to generate a report. And if you take a look at that image that's highlighted in blue here, you can see that this is an example of how we're creating that security group in Bodo, right, in Python. And this is how we're basically, once we create that security group, we're returning that information right back upstream. And that information is then returned to the incident responders or stakeholders who are subscribed to our SNS topic in a nice little email. So that's essentially EC2 containment, how we're doing that and how we're able to do that effectively cross-account. And then a nice little thing that I want to talk to you guys about is a bonus, collecting S3 objects from a forensic standpoint. So this is one of my favorite capabilities, wherein we're basically able to reach into a tenant account and collect the objects within inside of a malicious S3 bucket and copy those into a forensics bucket within the forensics account. So we have the ability here to be able to copy either all of the objects or a single object, depending on the payload that has been constructed by the incident responder. And if you take a close look, you'll see that with this case, it's a little bit different because the car role, we aren't assuming in the tenant account. We're assuming that car role first in a forensics account. And from the forensics account, we're copying the objects from the tenant account. So a lot of complexity is hitting underneath when it comes to having the bucket policies and KMS keys for encryption. The bucket policy for the malicious bucket must have a certain level of permissions in order for us to be able to gain access to it. And we also have to ensure that that role has permissions to be able to copy the objects from that bucket in the AWS tenant account. And then lastly, of course, if you're using any kind of encryption, KMS the CMK and the key policies must have the information that the roles whitelisted as well as the S3 buckets as well. So it's a little bit convoluted on the back end, but it is possible, and this is how we're doing it today. And if you take a look and you see here, we have an example of the CLI information that we use to execute to validate the fact that one of our for our forensics bucket, we can see the objects that have been copied over. And you can see that the path, and usually what happens is that in that forensics bucket, once we take a copy or we collect the objects from the S3 bucket, we create a folder with the name of the bucket and copy all of the objects inside of that folder just to kind of keep things organized so that we don't have a bunch of objects that we don't know which bucket it came from. So, and once that's taken care of, in the email, we'll send that to the incident responders. And then in that email, it'll also contain a list of objects that were copied, the S3 bucket, and the forensics S3 bucket that all the objects were copied into. So with CSAF, and this is going back to the Finetribe breach, when we use this to be able to contain all the resources, you can see that all the resources that were originally orange are now white. So all of them have been contained. And then on top of that, that ML data bucket, since this was one of the buckets that was also compromised in breach, we essentially copied all the objects from that ML data bucket into our forensics investigator bucket into the forensics account. So that's where S3 object collection, or the forensics portion of it, comes into play here, right? So just to kind of recap, and we're coming to the conclusion of our presentation, I'm going to list some of the benefits of CSAF and some further future enhancements as well. So by using CSAF in the Finetribe breach, we pretty much reduced the amount of time for containing resources from 4 hours to less than 15 minutes. Some additional benefits for this is that we also eliminated that possibility for our human user error for executing those containment and collection actions. For scalability purposes, we also are able to scale very well when we're executing those containment actions by the use of step functions. So if we had to contain 500 IAM users and 50 EC2 instances, we can easily do that. In addition to having the portability with the CLI tool that we have for this as well. And in terms of containing new services, if we want to develop new features, we can easily do that by extending our containment automation framework for those new features, because we leverage CDK and we're also developing everything in Python, et cetera, et cetera. So in the future, as we continue to develop those capabilities, we will add new support for some of the AWS services, such as Lambda and also EKS clusters, EKS nodes, and so on and so forth. So with that being stated, thank you all for attending our talk. And please, please, please complete the survey in the mobile app. Thank you.
All right.